Well, as we have seen previously, the UDP and UDP-based attacks in the last topic. So here DNS, domain name service, which is a service that utilizes the UDP at the transport layer. So this DNS is at the application layer. This is a DNS application layer service that will use the UDP at the transport layer. In turn, that transport layer will use the IP and in turn frames that is at the data link layer. Then it will go into the raw bits. So the domain name server, domain name service, the ultimate aim of this domain name service is to provide the names for the IP addresses. So the motivation is humans prefer pronounceable names rather than the numeric IP addresses. That means, for example, if I ask you what are the how many mobile numbers you can remember uh, so far. That means your friends and your relatives or your any one of your known people. How many mobile numbers you can remember? Maximum 5, 10, or maybe 15. Your good memory, if you have a good memory, maybe 20, 25. Okay, but not more than that. Okay, but if I ask you what are the names of your childhood friends and what are the names of your schoolmates, classmates, and your engineering classmates or maybe other batch members, so you can tell any number of names, maybe more than 100 also you can tell. So that means names can be, that means human readable forms or human pronounceable names can be easily remembered by the human beings than the numbers. But the computers in the world uh, will be recognized only with the help of IP address, even though they have the computer name or something. But mainly the communication will go and will will be happen only with the help of IP addresses. But the missions prefer the numeric IP addresses. So how can you remember all the IP addresses? It is very difficult to remember all IP addresses. If you can remember google.com, yahoo.com, or rediff.com, or any other email websites names, but you cannot remember the IP address of them. So, so that is the reason we need to have a mechanism to translate the pronounceable names to the IP addresses. So this mechanism are so the missions can understand. So this way of conversion from the pronounceable names to the IP address is said to be domain name service. So this domain name service will utilize the UDP as the internal protocol for providing the service. However, DNS will use both TCP and UDP. That will see when the DNS will use TCP, when it will use the UDP. Original naming scheme, flat structure. The original names formed a flat namespace without structure. A centralized site, a network informatics center, or administrated namespace. Later, NIC was replaced by the Internetwork Information Center. So whenever the flat space is there, the advantage is names are convenient and short. But the disadvantage is a flat namespace cannot generalize too large set of missions for both technical and administrative reasons because of the potential conflicts. So the same name may be used by some other people. Names are assigned by a central server, and so thereby everyone should depend upon the central server. Maintaining the correct copies of the entire list of at each site is very difficult process. So that is the reason it is better to go for other format instead of flat structure, that is hierarchical name structures, decentralizing the naming mechanisms, delegating the authority and distributing the responsibility. A hierarchical naming scheme works like the management of a large organization. The namespace is partitioned at the top level. The authority for names in subdivisions is passed to the designated agents. It is just like ftp.mail.gov.in. So here hierarchical name structure will be there. There is a ftp.mail.something like that. So here DNS query, that means if any service wants to resolve the IP address that is with the human readable name to the IP address, then the DNS queries will be used. We'll see what is DNS and its DNS queries and all. DNS specifies the name syntax and rules for delegating the authority over names, specifies the implementation of distributed computing system that efficiently map names to the addresses. DNS syntax will be like this: set of labels separated by delimiter character, which is called a dot character or a period character. So example is like this: ecs.syr.edu or jit.ac.in, like that. Top level domains is in edu or .ac.in, which is called academic institutions.india, like that. Mapping domain names to the addresses. So name server supplies name to address translation. Here the client uses one or more name servers when translating a name. Whenever you go for ping space jit.ac.in or google.com, whenever you are getting the reply, so you will not get the reply as a reply from google.com. You will get the reply from some so and so IP address. That IP address is the original IP address of the google.com or the google.com server in the nearby locality. So how you will know that this is the IP address? Obviously, this IP address will be resolved even though you have sent the ping command with www.google.com, and this name will be resolved by the DNS servers, which is called domain name servers. So the Google domain name server is 8.8.8.8. This is a default DNS service by the Google, so that can be used. So the client, what it will do is uses one or more name servers when translating the name. So DNS uses a set of online servers. So servers are arranged in a tree. That means even though you won't get the information of translation of the website name to the IP address at one server, then you can try for other servers. That means you can go, or the server may pass your request to some other servers to get the name resolution. A given server can handle entire subtree. For example, a server at ECS manages the domain names within the ecs.syr.edu, like that. Types of DNS queries here, then it is a recursive query or maybe iterative query. Recursive queries, in the sense, these are often used by the client, and iterative queries are often used by the local DNS server. So recursive queries and iterative queries. A recursive resolver sends this recursive query to a name server for information about a particular domain name. The queried name server is then obligated to respond with the requested data or with an error stating that data of the requested type does not exist or that domain name specified does not exist. That means simple that you have sent a ping command with a website name. Now this particular request may be going to the DNS resolver. So what this DNS resolver will do is DNS resolver sends a recursive query to a name server, that is domain name server, for information about a particular domain name. Now you need to resolve that particular domain name. The queried name server is then obliged to respond with the requested data or with an error stating that the data or the requested type does not exist. That means we didn't find so-and-so.com or so-and-so.in, this kind of thing. Then it is said to be a recursive query and a straightforward query, you will get it. But in case of iterative query will be done at the server level. If the queried name server is not authoritative for the data requested, it will have a query to the other name servers to find the answers. That means I don't know this answer. Now what I will do is I will forward this request to some other server, so they will respond. So it could send recursive queries to those name servers, thereby obliging them to find the answer and then return it to the requester. So thereby the passing of the request, whenever the server does not know or does not unable to resolve the names, So thereby, recursive, that is iteratively, the request will be forwarded to the name servers, uh, various other name servers, till the name was resolved. These are the ways the DNS queries will function. And during this process, just like how ARP cache will be maintained, whenever the ARP reply was received, all the computers who listen this ARP reply will update their tables. Like that, whenever this DNS resolving is going on, every device that receives this DNS request as a reply will update the corresponding IP address, that is name resolution and IP address in their cache, which is called DNS cache. Again, how we'll do the ARP poisoning? The attacker will focus on the performing of the ARP poisoning, and same thing, same kind of poisoning can also be done on the DNS, so that the man-in-middle attack will be successful when this DNS caching or DNS cache is poisoned, because the victim or the person may or a particular person may request for a website, and this website name must be resolved. But if the attacker is the one who can poison the cache of the DNS, then automatically the website will be redirected or will be redirected to the attacker's server. So this is the way DNS caching will be poisoned and attacks will be launched. We'll see some more attacks afterwards after discussing the DNS caching. DNS caching, after the local DNS server obtains the query results from the another DNS server, it will store the result in its cache for certain period of time. The timeout duration can be specified in the DNS response. Okay, so that means it's just like your ARP cache or the ICMP and its related caches. So how you are going to get the caches? Same DNS cache will also be maintained there for certain duration. This certain duration means it will be of around 20 minutes, 15 minutes. That much duration will be there. Till that duration, this cache will be maintained. Or whenever the system is off or system is turned on, or internet is off and internet is turned on, this kind of thing, that the cache will be cleared. Then whenever the next request has sent, then again the cache will be maintained. So I think you can no need to go in detail of how this cache process will be maintained and all, because already by this time you might have got the idea of how the cache will be maintained. Next one is DNS mapping and ports, especially. DNS server will always work on the 53 port. Okay, and in the DNS mapping here, inverse mapping will be there, implemented by a separate parallel tree feed by IP addresses. So 223.33.44.3 will be mapped to the sub domains like the 3.44.33.222.in address.arpa. So the internet root domain servers maintain a database of valid IP addresses along with information about domain name servers that can resolve each address. So that means many of the domains will be having the subdomains, like for example, mail.yahoo.com or mail.reddit.com or mail.webmail.com or mail.jad.ac.in or like how we have seen our G Suite ID. So these are the subdomains. Okay, under jad.ac.in again subdomain. So for subdomain also again separate IP address will be there. So once you know the main domain to the subdomain, or if you know the subdomain to the main domain, this kind of mapping will be performed in case of inverse mapping. While coming to the DNS port, as I told you just now previously, DNS utilizes both TCP and UDP services. But most of the time, DNS will be depending on the UDP only. DNS uses the TCP and UDP on port 53 to serve the requests. Almost all DNS queries consisting of a single UDP request from the client followed by a single UDP reply from the server. But when the DNS will use the TCP, if the size of the packet or size of the query crosses the 512 bytes, then TCP will come into the picture. So that means if it is a small size of the query, then UDP will be used, because even though it lost, it is not a problem. Again, you can try it. But if there is a large packet, then you need to take it carefully, because whatever the service is there, ultimate aim of every service is to give the best of effort delivery. So that is the reason TCP is typically comes into the play when the response data size exceeds 512 bytes or for such tasks as zone transfer. So in these cases, TCP will come into the picture. So don't say blindly that DNS will directly use the UDP. DNS uses the UDP, well and good. But DNS will also use TCP when the response data size is exceeded by 512 bytes. Now we'll see the DNS protocol attacks. One is unrelated data attacks, and another is related data attacks. Unrelated data attacks is like this. To improve the performance, DNS servers can send back more information than what the client has asked for. So this is what the main problem with the unrelated attacks. Already we have seen this kind of attack when in previously, that is even for small request, a huge number of packets will be sent back. In case of UDP, you might have seen in the UDP attacks. So same kind of thing will be there here also. To improve the performance, what will happen? Some DNS servers can send back more information than the client asked for. I have asked only the time information. I want only the time zone information. But what will happen here, instead of time zone, along with time zone, sometimes a DNS server will also give you other information such as linked times, daytime, night time, or light saving, many other things it may give you. So it is a big problem actually. For example, if a client asks for IP addresses IP address of mysite.com, the DNS server can also send back an IP address of its subdomains also, sometimes ftp.mysite.com, mail.mysite.com, to avoid another likely DNS lookup. This is a very, very dangerous sign. If such kind of thing was replied by the DNS server, then it is a very easy task for the attacker to get more information, or will keep on getting the more information about any other thing. So which is especially used in the reconnaissance phase to get as much as information possible about the target. While coming to the related data attacks, the process is same as the unrelated data attack. The hacker has to make the extra information related to the original query by inserting some additional options in that, like MX, CNAME, NS. MX means it will give you the mail server related information. CNAME means canonical name or alias names related information. NS means the DNS server for domain information. That means in the previous case, what will happen? Without having any specific options, it will give you reply with many options. Many optional answers will be given in the unrelated data attacks. Where in case of related data attacks, attacker will voluntarily attacker will design the queries in such a way that with the various options to get more information about the DNS server. So this is the related data attack. Next is reverse DNS attack. So assume that nyx.syr.edu and apollo.syr.edu trust each other, and the trust is based upon the name but not on the IP address. Also assume that you are from hacker.com and you have the control of your own DNS server. How can you exploit the trust relation between NYX and Apollo? When NYX receives the connection from an IP address, it need to use the reverse DNS lookup to find out the host of the IP address. The reverse lookup will start from the root, then goes to the ARPA.in address, and eventually goes down to the DNS server of the own IP address. If the IP address is the attacker's mission, the query will go to the DNS server of the hacker.com, which will tell you anything that they want, including saying that the IP address of the host name is apollo.syr.edu. So this is the because of the chain, or we can say the iterative query process that we have seen previously. Whenever the DNS query request was sent, because of the iterative thing, if one thing is missed in one place, then then other means if one server unable to resolve the name, then the request will be forwarded to another server. So like that, in this process, in this chain process, and in the reverse looking up, so sometimes the attacker may poison, or attacker may inject some false information there, thereby the original track may not be coming into the picture. However, it will go and will stuck up with the hacker.com as the genuine DNS server. So this is what the reverse DNS attack that can be performed. Next one is DNS farming attacks, aiming to redirect a website traffic to another bogus website. Many techniques can be used in this, and mostly targeting the DNS. Especially, if this will be done in a simple way with the help of the DNS cache poisoning. So here the insider attack, the corrupted insider can modify the local DNS server to mislead users to bogus websites. And a corrupted host will be there. If the host is already corrupted, there are many things the attacker can do to affect the DNS. User of the corrupted machines can go bogus websites when they visit their favorite sites. Here are some particular popular tricks by the attacker. Whenever you use a DNS server on a Linux operating system, the DNS names and corresponding IP addresses will be mentioned or will be available here in the /etc/host file in Unix system. Modify Windows host file to map specific domain names to the specific IP addresses. Modify Windows registry settings to refer to specific DNS servers. Creating a scheduled task under Mac OS to refer specific DNS services. Exploit cross-site request forgery vulnerabilities in routers to overwrite the DNS servers. That means once the system access was happened, whenever the system hacking was happened, once the system hacking is successful and the password privilege escalation is successful, this modifications can be done easily. In the ethical hacking course, I have shown you the one who attended the ethical hacking course previously, I will also give you the lecture video of that. I have shown you how to escalate the privileges by attacking by gaining the system access. So whenever you escalate the privileges, I have shown you there. You can create your own users. You can create your own users. In the same way, whenever you can create your own users, why can't we go for modification of this /etc/post, etc. So these are the things will be done whenever the system hacking was done. So automatically, whatever the entries are there in that, accordingly only the DNS will reply. So this is the way how the corrupted host will be maintained, can be done by the attackers. DHCP attack, basically this corrupted host and all can be identified via misuse detection in case of intrusion detection systems. Okay, where in case of farming attacks and previous reverse DNS and this kind of things, unrelated data, these are the event based or signature based detections can be done. DHCP attack, serving the rogue DNS server configuration over DHCP, the protocol responsible for distributing dynamic IP addresses as well as their information, including DNS settings. So it is again mainly attacking the DHCP protocol for misconfiguring of the DNS server configurations. Next one is domain registration attacks. That means every website need to be renewed for every 1 year or 2 years, depending upon actually annually they have to renew it. So when a domain registration expires and owner forget to renew it, attackers can buy that domain legally and hack the domain. Attacker can also buy the domain names that are similar to the targets, like SBI.in is there, SBI.SBVI, like that. With similar names, they may purchase and they may use it. So if the user misspells the domain name, they might become the victim. Next one is corrupting the DNS servers, change the mappings of the corrupted DNS servers. Next is DNS cache poisoning. As I told you how the ARP cache poisoning will happen. In same way, DNS cache poisoning. Victim DNS servers ask for the DNS services servers for mapping its, if it does not have them, then the DNS catches the mappings. The DNS cache poisoning is poisoning the client's cache, so thereby they will not get the correct mapping. Next is Dan Kamsky attack, an elegant attack that bypasses the cache effect. The idea is not to send a request for example.com if your target is example.com. Instead, send a request to the a.example.com. That means to the subdomain of the main domain, and b.example.com. In the spoofed reply, attach the IP address of the example.com in additional field. This way, if the spoofed reply loses to the legitimate replies, the IP address of the example.com will be cached. Okay, so because IP address is unlikely to be included in the legitimate replies, therefore the attacker can keep trying until own spoofed replies beat the legitimate replies. As long as the attacker cache winning the race is not zero, sooner or later the attacker will be succeeded. So instead of sending the request to the main domain, simply it is like a hunting around the bush. Okay, if you get it, then you will get it. So it is again the success rate is somewhat lower here, but still you can try it and get the information. So these are the various DNS protocol attacks that are possible. So to summarize, unrelated data attacks, okay, related data attacks, reverse DNS attacks, DNS farming attack, and DHCP attacks, domain registration attacks, corrupt DNS servers, DNS cache poisoning, and Dan Kamsky attacks. Most of the DNS attacks will be mainly focused on the misuse detection, and this, especially like cache poisoning and all, can also be detected via rules and all. And Dan Kamsky also based upon the rules. So this is what about the DNS protocol attacks. In the next lecture, we'll see the TCP related attacks.